Download this code from codegive.com, link in the description below. Observable Flutter is a library designed to work with Flutter, allowing developers to create reactive applications using observable patterns. The tutorial will guide you through integrating observable Flutter in a Flutter application, focusing on the use of the LLMS, Large Language Model Services, feature with the Gemma library. Prerequisites: Flutter installed on your machine. Basic understanding of Flutter and Dart. Familiarity with reactive programming concepts. Step 1. Setting up your Flutter project. 1. Create a new Flutter project. Open your terminal and create a new Flutter project. Bash. Flutter create observable _Flutter _demo. cd observable _Flutter _demo. 2. Add dependencies. Open the pubspec.yaml file and add the necessary dependencies for Observable and Gemma. YAML. Dependencies. Flutter. SDK, Flutter. Observable, 0.1.0 check for the latest version. Gemma, 0.1.0 check for the latest version. Then run. Bash. Flutter pub get. Step 2, creating a simple observable class. Create an observable class that will hold the data we want to observe. This will be a simple counter that we can modify. Dart. Import package observable/observable.dart. Class counter extends observable. Add observable. Int value equals 0. Void increment. Value ++. Notify listeners. Void decrement. Value. Notify listeners. Step 3, integrating Gemma for large language model services. Let's set up a simple integration with Gemma to simulate a request to a language model. You would typically use an API service here. Dart. Import Dart async. Import package Gemma/Gemma.dart. Class language model service. Final Gemma client. Language model service, this.client. Future string generate response, string input, async. / simulate a call to a language model. / replace this with actual API call using Gemma. Await future.delayed, duration, seconds, 2, / simulate network delay. Return generated response for, $input. Step 4, building the UI. Now, let's create the UI that will display the counter and a button to generate a response using Gemma. Dart. Import package Flutter/material.dart. Import package observable/observable.dart. Void main. Run app, myapp. Class myapp extends stateless widget. Add override. Widget build context. Return material app. Title, observable Flutter demo. Theme data. Primary swatch, colors.blue. Home, counterpage. Class counterpage extends stateful widget. Add override. _counterpage state create a state, equals _counterpage state. Class _counterpage state extends state counterpage. Final counter _counter equals counter. Final language model service _LM service equals language model service, Gemma client. String _response equals. Add override. Void init state. Super.init state. _counter.add listener. Set state. Future void _generate response, async. String result equals await _LM service.generate response, counter value is $_counter.value. Set state. _response equals result. Add override. Widget build, build context. Return scaffold. App bar. Title, text, observable Flutter demo. Body, center. Child, column. Main axis alignment dot center. Children, widget. Text, counter value, $_counter dot value. Row. Main axis alignment dot center. Children, widget. Elevated button. On pressed, _counter dot increment. Child, text, increment. Sized box, width, 20. Elevated button. On pressed, _counter dot decrement. Child, text, decrement. Sized box, height, 20. Elevated button. On pressed, _generate response. Child, text, generate response. Sized box, height, 20. Text, response, $_response. Explanation of the code. 1. Observable class. The counter class uses the @observable annotation to create an observable property. Whenever this property changes, it calls notify listeners, notifying the UI to re-render. 2. Language model service. The language model service class simulates a call to a language model. You will replace the simulated response with actual API calls using Gemma. 3. UI. The counter page manages the UI state, displaying the current counter value and a response generated from the language model. It includes buttons to increment or decrement the counter and to generate a response. Step 5. Running the app. Run your app on a simulator or physical device. Bash. Flutter run. Conclusion. You have now created a simple Flutter application using Observable and Gemma to demonstrate reactive programming and integration with large language models. You can expand on this by adding actual API calls, handling errors, and improving the UI as needed.